Hi everybody. Today we're going to do a case study taking a look at the digestive system. And so to start us off here, I've got some basic pre-reading questions for us to address briefly before we get into the story. Basically the way this video is going to work is you'll see some questions, we'll have some storytelling. Once you've seen some questions, you're going to pause the video, try to answer the questions on your own, actually write down or type up your answers, and then once you think you've got it or you've gotten as close as you can get, unpause the video, we'll talk through the answers to those questions, and then we'll move on from there. All right, so we're going to start off with these pre-reading questions. The first question is, why do animals need to eat? What actually is food, and what purposes does it serve? Second question is for you to create a basic diagram of the digestive system. So this doesn't have to actually look like the digestive system. You could use circles and squares and things like that. You're just kind of showing where the food goes and what's a part of this system. You want to include the organs of the digestive tract. Those are the ones the food moves through, and also what we call the accessory organs. These are the ones that dump stuff into the digestive tract. I'll give you an example, which would be the salivary glands in the mouth, which add saliva to the food while it's being chewed. And then I want you to challenge yourself to define the function of each organ that you diagram in 10 words or less. All right, so please pause the video, take the time to attempt these questions, and we'll see you in a minute. Welcome back. All right, so first question is, why do animals need to eat? What is food and what purposes does it serve? So basically, if you're a living thing, you are made of matter. To be more specific, you're made of things like proteins and lipids and carbohydrates and nucleic acids. These are all big molecules. And as you survive, you need to replace the matter that you are made of. You need to provide energy to live with. You need nutrients to replace nutrients that are lost in the normal course of living. And you need to provide raw material to keep building or rebuilding your body. So essentially, think of yourself as a Lego structure or something. Little bits of you are being lost to the environment over time or need replacement. If you want to keep yourself whole and functioning, then you're going to need to replace those bits and pieces. And that's what we do by eating food. So food is going to provide us with energy. It's also going to just provide us with the raw materials that we need to construct and to reconstruct or rebuild our bodies. All right, next question says, create a basic diagram of the digestive system. So let's take a look at a basic diagram. All right, so here is a diagram that is not so basic. This is a model from a great site called BioDigital that you can use to take a look at human anatomy and physiology. And so right now we've turned off a bunch of the organs and the muscular system and things like this. And I just want to show you the digestive system here. So I'm going to actually turn off some more organs here. Let's get rid of the skeletal system. Let's get rid of the nervous system. All right, now we're just looking at some of the major organs of the respiratory and digestive and cardiovascular system. So let's even get rid of a bit more of that. Let's get rid of the respiratory system. Let's get rid of the urinary system. Let's get rid of the cardiovascular system. So now we're really just looking at the organs of the digestive system. So you can see up here at the top, we've got the mouth. Food would go down from there into the esophagus. The liver's kind of in the way here, but you can see then we're going into the stomach. The stomach is then going to attach to the small intestine here, which then wriggles back and forth until eventually down here it connects to the large intestine. The food then comes back up, crosses over across the front of the body, and then exits the body through the rectum and anus. So this is our digestive system. You'll see there's some other organs here as well. The pancreas, that's the gallbladder, the liver. Everything's kind of crammed together in a small space. So it's kind of difficult to make sense of exactly what goes where and when. So let me show you a really simple diagram. This is what we call a schematic diagram, kind of like a subway map, right? It just shows you how things are connected. It doesn't actually try to realistically depict what we're looking at. So here, the whole digestive system is basically just a big tube that goes from mouth to anus. And so food's coming in here, stuff's happening to the food, and then the food is exiting here. And then along the way, highlighted in green, you see these what we call accessory organs. These are things that add secretions into the digestive tract to help you digest and process your food. So let's try the task of defining the function of each of these organs in 10 words or fewer. All right, ready? So we'll start with mouth. put the food here and chew it up. Also, saliva. There we go. So the mouth is the place where you chew up your food. You start that process of breaking it down. Salivary glands secrete saliva that has digestive enzymes like amylase and lipase. Amylase breaks down starches, lipase starts to break down lipids. So your salivary glands are moistening the food and helping with that mechanical breakdown that your teeth are doing, but it's also beginning the process of chemical digestion through the addition of some digestive enzymes. Esophagus, move food from mouth to stomach. Oh boy, oh boy. It's basically just a tube that squeezes the food down into your stomach. So it's not just a passive tube, it is actually through muscular contractions called peristalsis, moving the food from the mouth to the stomach. So you could drink water upside down and the water would eventually still get to your stomach. Your stomach digests food with acid and enzymes and also some churning. So this is a place where that mechanical digestion is continuing because the stomach is moving around, contracting to mix up the food. It's also the place where acid is coming in. That's going to help denature the proteins found in your food. And you've also got some enzymes coming in here, most famously pepsin, which breaks down proteins. After the stomach, we're entering into the small intestine. Most chemical digestion happens here. Most absorption also happens here. So the small intestine has two super important purposes, which are one, to finish out the chemical digestion of the food. That's the breakdown of the food from larger molecules to the small monomers that will absorb into our bloodstream and use to rebuild the various bits and pieces of our body. So breaking the food all the way down into things like simple sugars, like glucose or fructose, break things down all the way down into amino acids like glycine or tryptophan or histidine or glutamic acid or whatever else, so that then those small molecules can be absorbed back into our blood. What about all these over here? Liver produces bile. That'll do. Gallbladder stores bile. Pretty good. So what is bile? Bile is a secretion that helps to emulsify or dissolve the lipids that you've consumed, the fats, the oils, so that they can mix evenly with that watery environment of your gut and then be more easily broken down and transported into your bloodstream. Pancreas secretes loads of enzymes like amylases, proteases, lipases, and more. So your pancreas is, you may know it from its association with producing insulin and glucagon and regulating blood sugar, but it's also producing a ton of digestive enzymes, which it dumps through this shared canal here into the small intestine to facilitate digestion. Large intestine continues absorption, especially of water. Also, home to many bacteria. There we go. So absorption of water, large number of your bacteria that you harbor live here and do cool stuff like make vitamin K for you that you wouldn't be able to clot your blood without. Thanks, bacteria. Rectum, store the poo. Anus, poop out the poo. Also, keep in the poo. Good. Important to poo when you need to. Also, I don't know if this gels with your life experience, important not to poo when you're not supposed to, okay? And if that's a hot tip, then you're welcome. All right, those are the questions for part 1. So let's dig into the story for part 2. All right, here we go. Ready? Follow along with me. I'll do all the voices. I hope you enjoy it. This case study is called Independence. Part 1, West Pakistan. June 1971. The girl's mother spooned a helping of rice and dal onto a banana leaf and set it on the packed dirt floor beside a little tin cup filled with river water she had boiled earlier. Eat up, Rima, her father coaxed, a broad and tender smile lighting his face. Show your little brother how. Then he gave her mother a kiss on the cheek and stepped outside to check on the animals. Rima was 9, plenty old enough to help with the keeping of their home and with the tending of their milk cow and their small flock of geese. and when her parents worked, her little brother Anuj was hers to keep and care for. She lifted the boy and placed him in the nest of her crossed legs. With her right hand she pressed together a ball of lentils and rice and brought it to her mouth. She was hungry, and it was good. Her mother could do a lot with the little they had. Mmm, so tasty, Rima said with exaggerated enthusiasm. She rubbed her belly and smiled at Anuj, then gestured at the meal on the floor in front of them. Go on. Anuj looked at her, his brows furrowed around his dark eyes. He reached out and slapped the food, laughing. Bits of yellowed rice stuck to his fat little fingers. He shoved his hands in his mouth and brought them out clean. That is one way to do it, their mother grinned. Just then their father burst through the doorway, his eyes wide with fear. They're here! Who is here, Baba? Asked Rima, terror rising up in her throat. Bad men, Rima. Dev saw them on the road. They are going from village to village, killing. Their father turned and held their mother's face in his hands and looked into her eyes. We must cross the border into India. This is our home, their mother shouted. Can't you talk to them? As if in answer, the sound of gunfire and screams erupted down the road. Rima held Anuj to her, closely. They heard angry shouting in the street outside their home and a crunch of boots moving toward them. Rima saw her father pick up the machete leaning against the doorway. Go now! Get out the back window! Get into the trees! He hissed, hefting the machete. I will find you in India! Rima's mother climbed through the window and Rima passed Anuj to her. As Rima climbed through the window, she saw shadows darken her doorway. Her father pressed himself against the wall beside it, the machete held high. He looked to her with urgency in his eyes. Go, he mouthed to her silently. Rima felt her mother's hand on her wrist, and soon they were running blindly into the forest beyond the village, tripping over fallen limbs in the twilight and picking themselves up, running, moving, desperately, desperately, away from the guns and the screams and the ruin of their lives. Hours later, when they could run no more, they collapsed on the banks of a river. Anuj was crying. Rima's mother stared at the horizon and let out long, mournful sobs. In the distance, in the direction of their home, the trees were burning. Part 2. They followed the river. They knew it flowed southeast, toward India. They stayed in the forest, keeping the river on their right. Sometimes through the trees Rima could see torches. Sometimes they heard gunfire, and her mother would cover her face, and Rima would remember her father pressed against the wall with fear in his eyes. They did not risk going to the river except for water, and only at night, because there were men in boats with flashlights scanning the riverbanks. They had brought no food. They drank the water from the river, but could not risk a fire to boil it. It was on the third day that their mother became sick. She would go a little ways away to retch and vomit on the ground. They had to stop their journey frequently for her to defecate. Within a day she was so weak she could not carry Anuj. Her thirst became overpowering, and she often risked trips to the river to drink straight from the flowing water. The next morning, when the sun rose, she could not stand. Rima, her mother croaked. Her eyes were sunken into hollows in her face, and her lips were cracked and dry. Her arms were wrapped around her torso, and Rima could see that her fingertips were shriveled, like those of a child who has stayed in the water too long. Her mother's voice had withered from a rich, loving alto to a harsh and grating whisper. Rima! Her eyes lingered on the face of her daughter. She raised a shaking hand to gently touch her face. You must take your brother to India. Rima's face contracted in pain and fear as though stricken. Mama, no. I cannot walk, Rima. I will stay here. No, Mama, they will find you. Tears streaked down through the dust on her face and spattered the dirt. You have to walk. I cannot, Rima. You must go. I love you, Rima. Her eyes flicked to Anuj, who was slapping his hands against the dust a few feet away. I love you, Anuj, she whispered. She shut her eyes and drifted into a fitful sleep. Rima would not abandon their mother. She lifted Anuj and walked to the river and then to the road. There would be someone who could help. She had to risk it. But there was no one in sight. She feared that if she strayed too far she would not find her way back, so she returned to tell her mother of her plan. Rima set Anuj down and crouched beside her mother. She put her little hand on her mother's dust-caked head. Mama, she called. Mama, listen. We'll wait here in the forest until you get better. Once you're well, we'll keep going together. We will be quiet. Nobody will find us. Her mother did not stir. Mama? She was so still. Rima shook her by the shoulder. Mama, wake up. But she did not. Rima knelt down beside her, her face blank. She took her mother's hand and held it to her face. Mama. As she began to weep, she heard behind her the sound of Anuj vomiting. Okay, here's your next set of questions. Again, we'll bring the questions to you now. You'll pause the video, try to answer them on your own. You may need to do a little research, a little Googling, write down or type up your answers, and then come back and we'll go through it together. First question is, what symptoms has mama shown? And which symptoms are causing which other symptoms? So it might be that you see symptoms A, B, C, and D, and you think that symptom A is causing symptom B, which is causing symptom C, which is causing symptom D. Or maybe symptom A is causing B, C, and D, right? So figure out the relationship between these symptoms after you catalog them. What are the principal dangers to health of vomiting and diarrhea? Clearly, these are two of the important symptoms, though not the only ones, that we need to discuss. What diagnoses would explain these symptoms? In other words, why is mama so sick? Why does she have these problems? What's the cause? Question 4, what are Anuj's symptoms? What might you predict about his condition in the coming days? So again, catalog the symptoms, and then based on the information you have already, make some predictions about what you think is going to happen. All right, so take some time now, answer these questions, write them down or type them up, and we'll see you in just a moment. Pause the video. All right, welcome back. So the first question that we have to address is just cataloging symptoms. So let's go back up to the case study and take a look at the symptoms that we have here. So the first symptoms that we see are vomiting and then frequent defecation, which is to say diarrhea. Then we start to see intense thirst and eventually weakness. She could not stand. She was so weak she could not carry Anuj, so muscle weakness. Then we start to see some more superficial symptoms with a deeper, more concerning cause. The eyes are sunken in the face, the lips are cracked, the fingertips are shriveled. So all of these, along with the muscle weakness and the thirst, point to dehydration. And the dehydration is pretty clearly the result of the frequent vomiting and diarrhea. So we're getting a lot of fluid loss from the vomiting and the diarrhea. This is causing dehydration. The dehydration is causing muscle weakness, as well as these superficial changes to her face and her skin as the body loses water. While we're up here, Anuj's symptoms so far, all we have is vomiting. So that's question 1. What are the principal dangers to health of vomiting and diarrhea? Well, it's fluid loss and dehydration, so simply the loss of water, but it's also the loss of other components which are lost in the expulsions, in the diarrhea and the vomiting. So things like salts, which are necessary for things like water balance and nervous system function in the body, would also be lost in the diarrhea and in the vomiting as well. So the core issues there would be dehydration and loss of salts or loss of electrolytes. Question 3, what diagnoses would explain these symptoms? So probably, maybe you keyed into this piece here. They drank the water from the river, but could not risk a fire to boil it. It seems like their mother has contracted some kind of gut infection. And so at this point, we don't really know enough to distinguish between the different possibilities, but we could be looking at a parasitic infection like Giardia, maybe something like a dysentery, or a cryptosporidium infection. We could be looking at cholera. This could be an E. coli infection. There's a lot of different gut infections. Also viral infections like a norovirus, for example, which could be transmitted through drinking dirty water and which would come with symptoms like this: vomiting, diarrhea, dehydration. So we can't really specify it from here, but GI infection, gastrointestinal infection, seems pretty likely at this point. As we said a moment ago, Anuj's symptoms at this point are just vomiting, but we've seen mama's health dramatically decline and quite quickly. Anuj being a little baby, we should be very concerned about his health moving forward. All right, we're going to move on to part 3 now. Here we go. Story first. Part 3. They found them laying on the forest floor, curled together, the mother around the daughter around the son. But when they went to wake them, only the children rose. It took all day to convince the girl, speaking to her softly, offering her food and water, showing her that they meant no harm, that they had lost their homes too, that they were going to India together. There was a camp across the border, in Bangaon, where they would be safe. Even so, when they left, they had to carry the girl away, so desperate was she to stay with her dead mother. They tried to explain that it was too late, that they had to go, that there was nothing they could do for her any more. They picked her up to carry her, and the girl bit and scratched at them, but was too small and weak to break free. Eventually, she consented to be taken along, sobbing soundlessly. If her brother was carried out of her sight, she would shriek and claw at them, so eventually the man carrying her and the woman carrying her brother walked side by side. As they walked, the woman had to stop more and more frequently to clean Anuj after he had soiled himself. She shared worried looks with the man Rima now understood to be her husband. They walked all day on the road. They were close to the border now, and the gangs of men did not dare to come so close. The group joined with dozens of others on the road, all filthy, all in tatters, all with the wide and staring eyes of people who have lost everything without warning and yet must, somehow, go on. By the time they reached the camp in Bangaon, they were a teeming river of desperate humanity. Thousands of them trudged, shuffled, or were carried. Rima had never seen so many people. As the camp came into view, Rima saw a vast field of tents and people, most gathered in the open. By now, Rima was carrying Anuj again. Down in the camps, most people squatted in the mud or stood huddled in groups. Now and then a person in uniform would come through with food or water. When one of these appeared, Rima approached him. "Please, my brother is sick." Anuj sat in the mud now. He didn't cry or move, but sat, mutely, shaking. The worker turned to her, his face sagging with exhaustion. "Medical tent," he said, gesturing to a large white structure in the middle of the camp. "Here, let me help. My name is Omar." The man lifted Anuj, and they walked together to the center of the camp. When they came to the tent, Omar lifted the flap so Rima could enter. She gagged. The medical tent was filthy, the ground covered in vomit and feces. All the beds were full, and people were laying on the ground, doctors kneeling in the filth to tend to them. The worker waved at a doctor. "Dr. Mahalanabis, we have another small child." A man approached. He had a mustache and spectacles, and he regarded Anuj carefully. "Are you his sister?" he asked Rima. She nodded. "Has he thrown up?" As he questioned her, he held Anuj's wrist, then peered into his eyes. "Yes." "Diarrhea?"
"What?"
"Pooped a lot, but water."
"Yes."
"It's the cholera."
"Will he die too?"
The doctor's face softened.
"You have already lost someone."
"Mama," said Rima, her lip quivering.
Tears pooled in her eyes. The doctor knelt beside her and took her hand in his. He looked her in the eye.
"We will do everything we can."
All right. Next set of questions. We've got a diagnosis. It's cholera. Here are your questions. What is cholera? How does it kill? How is it transmitted? Why are cholera epidemics common in wartime, after disasters, and in refugee camps like this one? And how is cholera treated? So take the time, write down or type up your answers, and we'll be back in a little bit. Okay, welcome back. Hopefully you have some answers. Let's take a look together. The first question is, what is cholera? So let's take a look. I've got a little graphic for you that I stole. Here it is. So cholera is a bacterial infection. So here's a little, cartoon diagram of a bacterium, which is representing cholera. It's an infection of the gut, of the small intestine, and it's spread mostly by dirty water and food that's been contaminated with human feces containing the bacteria. So this is what we would call the fecal-oral route of transmission. Basically, you get infected, the infection grows in your gut, you have diarrhea, you vomit, and you release more of the bacteria who've reproduced in your gut into your surroundings. Now, for example, if that feces flowed into a river and someone downstream drank from it, they could become infected. Or maybe you're cleaning yourself up and then you handle food or prepare food, someone eats the food, again, they could become infected. So it's the fecal-oral route. The common symptoms, as we've seen, watery diarrhea, ample watery diarrhea, nausea and vomiting, and then dehydration, which is the really concerning cause. If this dehydration progresses long enough, we'll see muscle cramps, rapid heart rate paired with low blood pressure. So as a result of the dehydration, it's harder and harder to keep that blood pressure up because there's just less volume in the bloodstream, and persistent vomiting and diarrhea continuing over time. How does it kill? Principally through the dehydration. So eventually you become so dehydrated that your organs start to fail, and death follows soon after. Next question, why are cholera epidemics common in wartime, after disasters, and in refugee camps? Well, it's because of the mechanism of transmission. So as we've seen, it's the fecal-oral route. It's coming because of dirty water, contaminated food. So in wartime, or after a disaster, or in a refugee camp, we're dealing with situations where there's very little infrastructure, like water sanitation plants, clean water pipes, opportunities to wash and bathe, sewage systems to carry away infected waste. These things aren't present, and that means the odds of interacting with contaminated material goes way up. And so that infrastructure could be gone because it's been destroyed in war, or people aren't maintaining it because of the war. It could be that it's destroyed by a disaster like an earthquake. For example, in Haiti, there was a big cholera epidemic after the most recent earthquake there. And in refugee camps, because these are huge gatherings of people in sort of impromptu cities that just are not equipped to deal with the needs of that many people. How is cholera treated? So principally two ways. Think of it this way. We've got a bacterial infection that causes severe dehydration. So we want to treat those two things. How do we treat a bacterial infection? Antibiotics. So oral antibiotics or intravenous antibiotics through injection into a vein. And then rehydration. So replacing those fluids, and we'll see the different methods for achieving that in the next section. All right, but if we can treat the dehydration and we can address the infection, chances of recovery are very good. If we can't, chances of recovery are quite bad. All right, here we go. Next part. Part 4. They found a cot that had only 3 children on it, and they laid Anuj down on it next to them. The doctor gave him some pills he mashed up in a cup of water and put a needle in his arm. Rima flinched when he put the needle in and looked at the doctor with concern.
The pills are to cure the infection that is making him sick. The needle is to put the water and salts he is losing back into his body. As long as we replace the fluids, he will be safe.
Rima looked around the crowded tent. Only some of them have the needle.
Yes,
the doctor frowned.
There is not enough.
He rose.
Rima, stay with your brother. He needs you now. Comfort him, stay close, and call one of us over if you get worried.
The doctor walked away into the sea of patients. Outside the tent, Dr. Mahalanobis and Omar watched eagerly as a truck slowed to a halt before them. The driver climbed out and opened the back of the truck. Volunteers from the medical tent streamed over and started to unload it. Dr. Mahalanobis, there isn't enough. Even with these trucks coming from Kolkata every day, not enough tetracycline, not nearly enough saline. Many will die.
No, they won't. Look.
He gestured to the truck. The workers had removed the intravenous saline and antibiotics and were beginning to offload boxes of plastic packets containing a white powder.
Take the packets and add clean water according to the instructions.
Oral rehydration? Dr. Mahalanobis, it has not been well tested. In the Philippines, 5 men died in the trial.
The measurements weren't right. They are right now.
We can't take that risk, doctor.
Omar, look around you. We admit hundreds of new patients every day. The population of this camp is nearly 300,000. I've worked in situations like this where the only thing we could do was to drag the sick and dying into the middle of the camp so they didn't infect everyone else. You say we can't take the risk? His voice shook with passion. We can't take the risk of not trying it.
He put his hand on Omar's shoulder and fixed him with a steely gaze.
Save the intravenous saline for the little ones and the patients already in shock. Give everyone else the oral solution, as much as they will drink.
Back in the medical tent, Dr. Mahalanobis gazed out at a sea of hollow faces and frightened eyes. Workers at the rear of the tent carried a body draped in a sheet.
This will work. It must work.
Questions. Question 1. What is the purpose of administering intravenous saline to patients with cholera? Question 2. What is the purpose of administering oral rehydration solution to patients with cholera? Question 3. What advantages does oral rehydration have over intravenous rehydration? Question 4. What is in the white powder? Why is it less effective to treat a cholera victim with water alone? All right. Take your time, answer these questions, write down your answers or type them up, pause the video, and we'll see you in just a minute. Okay, welcome back. So let's take a look at these questions. What is the purpose of administering intravenous saline to patients with cholera? Well, as we discussed before, the way that cholera kills is through serious dehydration. If we can replace the fluids, we can address the dehydration, we can save people's lives. So intravenous saline is literally putting salty water into the bloodstream directly, right? That's what we're trying to address. That should bring the blood pressure back up. That should rehydrate the organs. This is like the key thing. What is the purpose of administering oral rehydration solution to patients with cholera? Well, it's the same thing. We're trying to replace fluids. We're trying to replace salts. We're trying to counter that dehydration. We're just going through the oral route rather than the intravenous route. Next question is, what advantages does oral rehydration have over intravenous rehydration? Well, intravenous rehydration, in some ways, is the gold standard. If you can get those fluids directly back into the vein, that's ideal. You're going to reverse the dehydration the most quickly. However, it's not always possible to do that. First of all, that intravenous saline is going to be more expensive and harder to get a hold of. You're also going to need trained medical professionals in order to get the needle into the vein and monitor the administration of the saline. There's a risk then of infection of the needle site as well. So it's a great therapy, but it requires more developed medical infrastructure and it's more expensive. So in a situation like this with a refugee camp, they have to prioritize the usage of their intravenous saline on the patients that need it the most because it's a limited resource. On the other hand, oral rehydration solution is cheap. We're talking about pennies per liter. And if you can combine it with clean water or boiled water, then anyone can administer it. It's as simple as taking a certain amount of water, putting a packet in, stirring it up, and asking somebody to drink it. So it doesn't require any medical monitoring. It's very safe, and it's effective in rehydrating the people. So what is that powder? What is oral rehydration solution? So it's basically, the powder is salts, so things like sodium chloride, magnesium chloride, calcium chloride, things like that, and also sugar, specifically glucose. And so why do we need to, why don't we just give them plain water? Well, remember, with sort of two factors here. Remember, one is that as they're vomiting and having diarrhea, they're not just losing water, they're also losing salts. So we want to replace those salts as well. It's the lack of salts that's also causing problems. So we need to address both issues. The other bit is that if we can get them to absorb more salts into their bloodstream, then the water will also osmose more easily from the gut into the bloodstream. Now, there's another additional factor here, the glucose. You might think, oh, why are we putting glucose in there? Well, we want to, give them some energy to work with, and that's true. It's helpful, but actually, it turns out that the mechanism in the gut by which the salts are taken back up requires glucose. It's what we call a co-transporter or a symporter. It's a protein that binds to both glucose and salt simultaneously and pumps them both into the blood. So if one of them is missing, the efficiency of transporting the salts into the blood, restoring those salts, decreases. So by mixing all these things together, we improve the absorption of salt, sugar, and water. So this is a good way to address the dehydration, get them a little bit of energy, and address the salt imbalance as well. All right, next part. It is the final part, part 5. Anuj cooed and babbled as Rima poured the rehydration solution into his mouth. The medical staff had given her liters of it with instructions to make him drink as much as he could. It had been 2 days since they arrived at the camp, and they removed the IV after the first. Most of the patients followed a similar course of treatment. If admitted in serious peril, they were given intravenous saline in conjunction with oral rehydration. After the worst threat had passed, usually within a day, they could remove the IV. The refugee camp was so crowded now that after the IV, most patients were sent back into the camp with packets of rehydration powder and instructions to return if the diarrhea did not abate. "Hello, Rima." Dr. Mahalanobis crouched beside her and took a good, close look at Anuj. "He looks much better. You did a very good job looking after him. Your mother would be proud of you." She beamed, breaking into a smile for the first time since that fearful night in the village.
With Anuj in such good health now, it is time for you to go. We must make room for others who need our help more. Of course, you will take plenty of the drinking saline with you."
"But doctor, you said children without parents could stay here as long as they wanted."
"I did say that, didn't I? And I am a man of my word."
Now he was smiling. His eyes shifted, and Rima followed his gaze to a man standing at the edge of the tent, his hands clasped to his chest, his mouth open and his eyes staring with a mix of disbelief and utter joy.
"Baba!"
Their father ran to them, pushing through the crowds until he held them both in his arms. Big tears coursed down his cheeks as he sobbed and laughed. "You're alive! You're alive!"
"Mama,
"I know, Rima. They told me."
how did you live? Those men."
"They took me captive. I don't know why they didn't kill me then, but they didn't. We were on the road and they were ambushed and I got free."
"Oh, Rima!"
He squeezed her tighter.
"Will we go home now, Baba?"
"Not yet. It's not yet safe. But the people have formed a resistance, the Mukti Bahini. That's who freed me. And the Indians are joining us. When we do go back, it will be to a free country." His eyes sparkled, and for a moment he looked very far away. But then his gaze returned to his children. "But never mind that. Now we are together. That is all that matters." And Rima's heart was filled to the brim with love. The end. There's the story. A couple more questions to round it out. All right. So, here are your final questions. 1, how many deaths per year are attributed to diarrheal disease? And who dies from diarrheal disease and where do they live? So like sort of what's the global burden of diarrheal diseases? You probably have to do some searching on this. 2, how and why have these numbers changed over time? Have they gotten better? Have they gotten worse? Why? What other cheap and effective solutions can be used to treat or prevent diarrheal diseases worldwide? So take a second, pause the video, write down your answers or type them up, and we'll come back and talk about it. Ready to go? Okay, welcome back. So our first question is, how many deaths per year are attributed to diarrheal disease? Who dies from it? And where do they live? So let's take a look. So here is a chart of deaths from diarrheal disease worldwide. And the different colors show you different age categories. So you can see children under 5 make up, in 1990, the majority of deaths due to diarrheal diseases. And by the time we get to today, they still make up a very large chunk, but we can see that most deaths from diarrheal disease are among the elderly and the very young, so the very young and the very old. We can see that in 1990, we had worldwide 2.5 million deaths per year from diarrheal disease. That's a lot of deaths per year, one of the leading killers. And today, we see about 1.5 million deaths per year. So that's a significant decrease in about 30 years, but it's still a major cause of death, especially among the very old and the very young. So how do we get here? How do we reduce the burden of diarrheal disease? Well, one of the innovations is better sanitation around the world. So installation of things like sewers, water sanitation plants, these kinds of things that make sure that folks don't have to drink dirty water and so people don't get infected in the first place. Building out of medical infrastructure so that folks can be treated. And also, critically, the expansion of the use of oral rehydration solution, which was pioneered, as we'll see, in this situation that we're talking about right now, which is a real situation. It was pioneered at this refugee camp in Bungaon and became a first-line treatment for chronic dehydration caused by diseases like cholera or dysentery. So having access to a reliable, cheap method of treating dehydration without the need for highly developed medical infrastructure has been a key driver in bringing these numbers down. And that's amazing that it only costs pennies per dose, and it's had a huge impact. You know, we typically think the big breakthroughs in medicine are the really advanced things, right? The ability to, use a brand new drug to treat a cancer, or a new kind of brain surgery that fixes a problem, like really high-tech, fancy things. But in fact, sometimes the biggest breakthroughs are the really simple ones because they can address problems that are widespread and they can do so cheaply. So where are these deaths occurring? Here's a map today. And so we can see this is This is from, by the way, this is from vizhub.healthdata.org. So check this out if you want. There's lots of different things that you can select, and you can see, different disease burden. There's tons of data here. If you're curious, you can learn about that. So here we can see deaths from diarrheal diseases in 2019 around the world. And so the darker blue it is, the fewer deaths. The darker red it is, the more deaths. And if you look down here, by the way, you can see all these little dots here represent where different nations are. And you can see that most nations are toward the low end, where they're not seeing a lot of deaths from diarrheal disease. The vast majority of that 1.5 million deaths per year are occurring in just a few nations. So what we're looking at here is nations like Chad, Niger, Central African Republic. We also are seeing just higher rates more broadly in sub-Saharan Africa and in India and the Indian subcontinent more generally, and then in Oceania down here as well. We're seeing some elevated rates, though not as bad as in Central Africa here. So this is where we're seeing these things. They tend to be in places where sanitation infrastructure is not as well developed compared with other places like, for example, the US, 3.5 deaths per 100,000 per year, or here's Finland, less than 1 death per 100,000 per year. Okay, so there's the distribution. So we've talked about all these questions now. Cheap and effective solutions to prevent diarrheal diseases. These are things like providing sanitation services, going in and making sure that there are, in places that lack sewage networks, building toilets for people. Really, there's a budding movement to install toilets in parts of the developing world to provide sanitary disposal of human waste, so that, for example, the human waste doesn't lead to cholera outbreaks like this one. All right. So I hope that you find this interesting. This is a case based on a real situation. And cholera epidemics still spring up from time to time, and there's still a serious disease burden from cholera, and especially from diarrheal diseases more broadly. Let me just read the final blurb here for you to give you a little background on where this case came from. All right. In 1971, the government of West Pakistan, now we just call this country Pakistan, launched a military campaign against the people of East Pakistan to suppress the civil disobedience and nascent nationalism long simmering since the British partition of India in 1947. So if you don't know about this context, India and West Pakistan and East Pakistan, so that would be India and then the modern nations of Pakistan and Bangladesh, used to be one big nation which was run by the British Empire. And so when India gained its independence, these countries gained their independence, and the British said, okay, well, sure, you can manage yourselves. They partitioned these countries up, and they said, okay, this is a country over here, we're drawing a border. Here's a country over here, we're drawing a border. And a lot of issues came from this kind of, not arbitrary, but this partitioning of this region into separate nations. So one of these was that you had, like, if you look at a map here, let me bring up a map here, right? So if we look at, here's India, right? Here's Bangladesh. Here's Pakistan, right? So Bangladesh over here and Pakistan over here, those were one country. In the British partition, they said, okay, Pakistan consists of this territory and this territory over here. So the people in Bangladesh, their central government was thousands of miles away, separated by another country. Pretty bizarre. And so the people of then East Pakistan, now Bangladesh, wanted to be an independent, self-governing place. The people of West Pakistan, or I should say the government of West Pakistan, didn't like that very much, and so went to suppress these, what they perceived as a rebellion, what the people of Bangladesh saw as an independence movement. So what happened? Military personnel, teachers and intellectuals, and people who wanted an independent East Pakistan were summarily executed. The Pakistani military and Pakistani-supported militias carried out massacres, especially in the capital city, Dhaka. 40 million people were displaced from their homes, including 10 million who fled to India to escape the fighting. One of the largest refugee camps was in Bangaon, just miles from the Indian East Pakistani border. Here, over 300,000 refugees waited out the storm, but cholera followed them and spread rapidly, and thousands of cases of the infection broke out in only a few weeks. Due to the interventions of the medical staff, almost all of the infected survived. In the camp of Bangaon, 3,703 patients were treated for cholera. The mortality rate, usually 30% or higher in cases of untreated cholera, was less than 4% in the camp. The success of these measures was due principally to the use of oral rehydration solutions under the leadership of Dr. Dilip Mahalanobis. These solutions were effective in controlling the dehydration, which resulted from cholera infection and could be administered by anyone with only rudimentary instructions. As a result of the success of this field trial, today oral rehydration solutions have saved over 50 million lives at a cost of only pennies per dose. Being inexpensive and simple to administer, this therapy has delivered particularly spectacular results in the developing world. I hope this inspires you to think, what are the biggest... A lot of the cutting-edge research you see in the laboratories at our universities are focused around treating diseases which deserve attention, absolutely, but represent a small amount of the disease burden around the world. I hope it inspires you to ask the question, what is killing the most people? What is causing the most suffering worldwide? And are there ways that I could work through my career, through my work, to address that? If you're interested in getting the maximum goodness for humanity, I think that this is an inspirational case where millions and millions of lives have been saved with a really innovative and really cheap method, and the impact has just been enormous. So thank you for coming along on this case study journey. I hope you found it interesting. I hope you enjoyed it as much as I enjoyed writing it and reading it, and we'll see you next time. Goodbye for now.